The benefits offered by a library like Zord for the JS software that's built and shipped today is twofold or multifold. First, it comes with a language to define validation rules to represent simple as well as complex values in your system application. We call the process of schema definition. And the way we go about this is we kind of define the structure that represents the kind of data our application works with. And then we basically tell what to do with that sort of a structure. Folks who are coming from the B domain or folks experienced with DBs know that many libraries that work with the DB let you define structures that validate incoming data to see if it matches the format that the DB stores or the system expects. This concept was later brought to JavaScript ecosystem with many validation libraries. The very first library I worked with, which brought this concept in my, set of tools that I used to work with was Joi. Joi was a kind of a utility library that shipped with a framework, Harpy, which was used to kind of develop a Node.js-based web application the way, Express is used today, right? And it came with these conventions to define objects and keys with the shape that will tell about whether, certain attribute can expect a certain value or not, and what could be the validations that could be, applied to ensure that the data that the system receives is correct data to work with, right? You'll see this concept very prominent and very popular in the front-end ecosystem also. Joi is kind of a library that's kind of front-end and back-end agnostic. It's a utility build, so you can just use it all across. Similarly, Yup is also quite popular in the React ecosystem, and it's used as a library to kind of, again, define similar structures we call schema, where you can declare attributes and you can tell whether those attributes are a string or number or date, and add further validations to ensure that whether they are as per certain constants that we want to impose or that we require, right? Data is the most key aspect of any system, and once you start working with known data, with data that you can truly rely on, you reduces the chance of errors that could kind of bug you in production and could lead to serious issues, right? And it's necessary to have a utility by your side that you can use to prevent a host of errors that your system may encounter due to just inappropriate or incorrect data. Now Zord, since the topic of this video is Zord, take this up a notch by being TypeScript focused. Out of the alternatives that we just browsed and hovered over, Joi isn't built for TypeScript ground up, right? You can use it in a TypeScript system, but all sort of validation that it carries out is a runtime validation, which means those validations apply only when you are actually running the project. These validations cannot be used while you are compiling it, or these validations cannot help you with type safety. So this option is out when you are kind of building software in 2023. Yup is another great alternatives, and I'd say that, if you wanna look into the alternate ecosystem of how to validate your data, how to flexibly work with the known data shapes, and how to also use TypeScript with it and be very kind of productive with it, then you can also kind of explore Yup. But the topic of this is Zord, so we'll see what Zord lets us do. So Zord first, just like the other alternatives that we considered, lets you define the shape of the data. And once you define the shape of the data, you can flexibly work with those data shapes by kind of telling whether, those properties could be, a string or number, and then you can add further layers or further layer of constants on top of it. Since Zord is TypeScript first since the very first day, and TypeScript is the de facto standard that's used to build the modern JavaScript software, you can be pretty assured that you are in the safe hands. Since Zord is TypeScript focused since the very first day, the same structure that you are using to kind of create the schema and tell what sort of data it could expect, you can use the same structure to infer the type, right? So first, you are defining your structure in just one place, and then next, you are not retyping the structure, right? You can just use this magic Z-infer, and then you can easily understand that type that structure holds. And then you can portably use this doc type to work whenever there is a requirement to work with the doc data in your system, right? This cannot be resolved with a library like Joi, which is a pretty capable library in its own sense. And if you are totally with the JS ecosystem today without TypeScript, you can totally rely on it. But TypeScript is becoming the de facto standard today, for the type guarantees. So the schema is the heart of your system. Schema is your final source of truth, which Zod uses to first understand the structure of the data your system will work with, know about the validation that it is supposed to perform, and then later infer the types, right? So let's just start with a very simple validation. Let's just say we have something called user name schema. The way we define this is we write something like Z string. Now this is simple and sufficient enough to tell that this value holds a string type. And once we have this value kind of declared as a string, we can consider that you are receiving data from, say, a form. Then what you do is you will take that data, say it's after, and then you will use user name schema dot pass to validate this data, right? We are using user schema dot pass to validate this data, right? First you declare the type of the data, and then you are using the pass. Now let's just see what it returns to us, right? It's all working. What if we pass something else? What if we pass something like 22, invalid type, string, received number? So it's correctly telling us that, we provided an invalid type. It expected a string, but we provided a number, and thus it's a wrong data type. We provided a Boolean value. It will update and tell us that, we provided a Boolean value. We provide an object. It will correctly warn us that we provided an object. But as soon as we provide a string value, it will just simply work for us, right? Once you have this available as a guarantee that the only type of value it could receive is a string, you can further add more rules or constants around it. What if you want to check the length of the string, right? You can do something like 3, right? It satisfies and it's working, right? Now let's just change the value to AF. 2 is small, minimum 3, inclusive, true, exact, false. String must contain at least 3 characters. So it's not just that it's telling you about the type of the error, it's also telling what type of error it is, and and also kind of a formatted message that you can use to kind of inform your users about the validation issues. The path is empty, but we'll see its significance soon because we are working with a primitive type, right? Now let's just change it to something like max 3, right? What will happen, right? The value is currently 2 characters, so we'll just change it to AFF. Again, it throws an error and says it's a wrong entry, right? Now let's just do away with it, because that's not the only validation it shifts with. You have a lot of values and validations available to you. You can use something like a CUID to check for CUID or unique identifier values. You can have something like a datetime to accept only the datetime values. You can have something like an email to only allow for a email field. Let's just see how it works, right? Validation email is just error for us. And as soon as we'll add a @ sign and we'll do something like com, it will pass for us. Similarly, you have something like a URL to only accept the website values, right? So what if it's not a username schema and it's the user website schema or the Twitter URL, right? Then you'll use something like a URL, and you'll go ahead, and if you type this will pass for us, right? So a string ships with almost all of the rules and constraints that can let you kind of sufficiently represent the type of the data it could accept, and also the constraints that you would like to impose, like the minimum length, the maximum length, or the values kinds it could receive, like an email or a URL or anything like that. Just see how exhaustive it is, right? You can have ends with, you can have its UID, you can have is datetime, is email, right? What if you change it to date time? Let's just see what happens if we change it to date time, right? Once we do the date time, the only value it can expect or accept is the date time value. Now, how we can provide the date time value? So that the date time values must be the UTC string format. So it can now only accept the UTC string format, which would be something like 23, right? And then now we can have something like 0000 set, right? It accepted this. So you'd use a string to represent anything that gets accepted in a system as a string, but then is later validated for some other representation like an email or a URL or a date time, right? Similarly, what if this is a number? This is something like a user age schema, right? Now, the string cannot sufficiently or correctly represent it. So now what we'll have to do is we'll have to convert it to something like a number. And once we have this here, the only value it will accept will be the number type. It's correctly warning us that it expected a number, but we provided a string, right? Now let's just provide a number, right? It's happy. Once you have a number, you have value, it's min, right? It says it's too small. Let's just change it to 90. It accepts it, right? What if we make it a max value? It will fail again, right? Now we can pass it by just providing 70, right? It works. Not just the lower range or the upper range, you can also have things like LT, like less than, LTE, less than or equal to, GT, greater than, or GTE for greater than or equal to, which is equivalent of having something like less than equal to, greater than, or greater than equal to in JavaScript. Not just that, if you just see it in action, if we make it LT18, it's satisfied, right? Now let's just provide 19. It will again error for us because number must be less than 18, right? Now, it's not just around ranges or the values. We can also have something like int. What if somebody provides a floating value here, right? Let's provide you a floating value, invalid type. It expected an integer, but you provided a floating value, right? Once we have an integer, what else we can do? We can also say something like positive. Now, what's a positive value? A positive value is anything that's greater than 0, right? Let's provide -1. It errored for us, right? What's a negative value? Negative. It satisfies. Now let's just remove this. It failed for us. We also have alternate versions like non-negative, which means anything greater than equal to 0. So 0 is now kind of acceptable value. And we also have something like non-positive, right? So this works for us. Now if we provide something like -1, it will work for us, right? So you get all sort of, kind of validations, almost all sort of validation that you would like to have around individual values, right? Not just this, besides string and number, it has also got a pretty extensible list of other properties, like you have something to represent a Boolean, to only accept the Boolean values, right? It's happy now, right? Or See if you want to expect only one value called ready, right? Any other value is going to be rejected now. Only value it will accept now is the ready type, right? What if you have a range, right? What if you have something like a gender? What if it's not age, but it's the gender you want to validate? It cannot be something like just M, right? M. Though this will pass for us, this doesn't sufficiently represents all of the gender a system could expect, right? So what we'll do here, we'll use something like enum M. Cool. Once we have this particular method will be able to help us in providing an exhausting list of property that we could expect. Now M is a passable value, but O won't be a passable value. No, O would be because we have provided others. L won't be a passable value, invalid enum value, because it expected an MFO, right? So that's how you kind of work with things like string, number, Boolean, enumerations, literal values, everything you desire for to have a kind of a structure around and functionality around out of a validation library is made available to you out of this library. The second great thing, which is type inference, right? Now, you have a user gender schema. How you could, understand the type that it holds, right? The way you do it is you have something out of this library called infer, right? And the way you use it is you create, say, something like user gender, and then you provide it infer type of user gender schema. What's the type? MF, Now you have a portable user gender which you could export out of your code and use all across the system, right? And not just this, once you say create something like an enumerated value and say you're using it to validate something or to kind of just create a value that kind of satisfies this condition, you'd have something like user gender in your system, and you'd use something like user gender to kind of correctly assign the value it can hold, right? F, M, and O. But what if you omit this and you want to use kind of magic inference sort of a property? You can actually do something like enum F, right? Now let's see the type for this. It's F, right? The literal value got assigned, right? So that's how it also helps you with the correct typing of the structure you'll use, right? Now, we have seen how it helps us to work with a date value or a string value or a number value or a Boolean value. Now, let's just see how this can be used with more complex structures, right? Let's just say we don't have a user gender schema. We have a full user object, which is something like this, right? And the way you define a complex object is you use this object function that's available out of Zord. Once you have this defined, now let's just see how this works, right? It expects only user schema, right? The type it receives is the Zord type. You have a data, which is M, and you are parsing it. Now let's just stop parsing. This is invalid. Object received a string, expected object received a string. The only value that could satisfy it is something like this, right? Happy, name, string, len 5 is int gt greater than 20, multiple of 5. Multiple of 5 is interesting because we are not just saying that, it will be greater than or equal to 20. It will be also a multiple of 5, which means that if you put something like a 21, it will be an error in George's sense, right? Number, again, is a number primitive with a minimum value of 10. Addressive, we're saying is going to be only a number. Is_admin is a Boolean value. Created is a string with the datetime value. Center schema we use from the above. And then we defined TNC as a Boolean value, but it's optional now, which means that whether this value is present or not, it won't matter when the value is passed, because it will consider it as an optional value, right? Now, when we are inferring this, we can just place this user schema over here, and we can see the type being inferred properly for our users, right? Now you see the type being inferred correctly for our users. Whenever you are receiving data from a form, or whenever you are receiving data, say, from a backend, this is a nice way to declare the shape of the data you expect to receive from an API, and then use the parse function to actually validate if the data is of the right shape, and then use the infer function to actually introspect and understand its type in a more automated. And this is the right way to first parse the data, validate whether it's correct or not, and then use the infer to derive the type that can be portably and reliably used across your entire system, right? Having it in one place centralizes things and makes the code consistent overall. So parse is just one way of kind of parsing the data. You have another alternative way, which is kind of a more elegant way to kind of parse your data, which is called safeParse, right? Parse basically throws an error when there is incorrect data, or just sends you the structure. safeParse gives us a more structured, way to kind of validate data. This lets us do is we can have something like cost validated and user schema safeParse data, and then we can use this validated to write conditional logic based on whether there is a success or error in parsing the data, right? So once we have this structure, if the parsing is successful, we can just console log validated data. This data is only available when there's a success of the flow, when there's a success of the validation. It isn't available over here, right? If you do something like validated data, it won't be available. The only thing available here is the error property. Now let's just log the error property, and we'll be able to see the error available here. What if it's a success, right? Let's just change it to the success value. Now you can see that we have all of the data passed correctly, and we have the data. So this leads to a more elegant structure for your code. And I recommend that you use safeParse when you desire to improve the readability of your code. Now, once you have this defined, what you can actually do is you can use some more convenience functions like partial. Partial means that it's allowed to have this object insufficiently represented, right? When it's sufficiently represented, the validation will carry out. When it's sufficiently represented, the validation will carry out and succeed. But when you have the value partially, it will still pass. So partial is used when absence of a key doesn't concern you. So do use it only in the scenarios where that's possible. Whenever you are working with the data or a structure where you have all the required attributes, it won't be a recommendation to use it, right? The way it influence the type is when you declare the structure as a partial, every key that that object holds becomes an optional key. so that your TypeScript interpreter is also happy that that some of the keys are just not necessary, right? Other than partial, you also get things like extend, right, which lets you add more feature to a predefined schema, right? You have a user schema, you can use extend to add more properties to it. Like, what else we can add here? Let's add a updated date, right? We'll declare it as a Z string, and then we'll declare it as a date time, updated date time. Now, let's just see the type for this one. The type doesn't say as much yet because we extended it. So now we'll have to choose the extended version, which is user ext schema, and now this validations should be carried out against the updated schema, right? It's invalid because it wasn't able to find the updated date. As soon as we'll provide the updated date, it will work for us. Updated date, updated date, right? It's happy now. Similarly, when we are inferring the type, the same magic is available to us, right? We have got the updated date. You can do this, or you can just create another type and use it over there, call it user extended, and then you have now two types representing two different states of your users. The same can be used for representing something like a common users of your site or something like user admin, right? The only thing that's different between user schema and user admin schema could be this as admin property. Let's just cut this one from here and paste it over here to represent a user admin schema. And now when we're passing it, it could be user admin schema. It's happy now. And this could be passed as a user admin schema. And then the type could be redeclared as user admin. And there could be two different places to say parse both of these validation rules, validated user and validated user admin. Let's make it validated user default. Let's convert it to user schema. And now let's just change this to validated success. It's working. Similarly, we can carry out another validation over here, like if validated user admin dot success, then only it will pass. Now, when we put partial here, we noticed that this inference was able to kind of infer that every property that is available against the user schema is an optional property. And if we hover over the user admin, we see that every property that was available around the user schema is still an option property. But is admin, since this kind of extended the user schema, it has is admin as the mandatory property. Now, what would be the reverse of this? What if we want to make everything that's optional to a mandatory property? Just don't need to kind of make every property optional. But what we can do here is now we can change this to required. As soon as we'll mark this as a required property, even the one properties which are marked as optional will be converted to required properties. Now, if we look at the inferred type, name, age, mobile, address, zip, created, and gender, and TNC, everything is now a mandatory property. And similarly, every user admin property is a mandatory property, right? So partial and required together helps us kind of take entire structure, entire object, or a scalar value and mark it as either optional entirely or required entirely. A structure to also work with. Now, let's just kind of try to kind of change this address div to another structure. Let's just create another schema called const user address schema. This is gonna be an object type, and within this object type, we're gonna be having several properties like address line 1, which is going to be a string. Another one we're going to be having is address line 2, which will again be a string. The next we can provide here is we can provide a city, again a string, state, again a string, and country. This could be enum, but for simplicity's sake, we will just keep these as a string. Now we'll just take this structure. We missed zip. Let's just add the zip value also. This will be a number with min equal to 5. No, but min, let's just change it to a more character structure. Let's just kind of convert this to a string and then provide a min of 5. Thing. Let's just kind of convert this to another nested structure like address lines, address, and we'll call it an object again, and within it we'll have something like address line 1 and address line 2. Let's just change this to line 1 and line 2, right? And let's just infer the type also. Type user address set infer user address schema type of user address schema. It's all mandatory. As soon as we'll make this optional, we can see that every field, no, as soon as we'll mark this partial, every property becomes an option property. But if you look at this marks address as an option property, city as an option property, state, country, and zip as an option property, but it wasn't able to mark line 1 and line 2 as an option property. Now how we could resolve this is there comes another method called deepPartial, which will take care of marking every nested structure as optional too. So it deeply goes inside the nested structure and marks every property that's inside it as optional property. Now say you have a schema like this site preference theme where you are allowing light, dark, and system as the only value that the system could expect to receive. We can maintain another shape around it like site preference theme. And this what happens when this value is used to parse the outcome, right? Let's just see. We took the site preference and we pass it, right? Invalid type, it expects an object, but all it got is nothing, right? Let's just put an object over here. Expected light darkened system, received undefined, code invalid, message required, right? Why did it happen? It happened because we marked it as mandatory, but we didn't provide the value. Now, what should the value be? Values. Now, there are two ways to go about it, right? Either we always provide the theme value, and that could be light, dark, or any other similar value. Or what we can do is, since this is not that sort of a mandatory property, what we can do otherwise is we can put a default here to say that there could be an assumed value whenever this key is present. As soon as this will get passed, even without a passed parameter, you'll be able to notice that the parse will be able to return the value that we initially provided while setting this up. Change this to something else, and it will be able to correctly reflect it, right? Theme dark has got applied. This is helpful in scenarios where you have values like created, which always get the time when a user entry is created, right? So something like this can definitely use the default, and then on top of it, what it can do is it can have something like new date, get UTC date, and then stringify it to a value that it expects to receive. Now, whenever user schema will get passed, we can be sure that even when this value is not available, there will be a value that the system can sanely default to. Now, what will happen if we provide a property that this particular schema doesn't expect? Let's put something like location, and then location could be a string. Let's disable this for the moment. Now, address is something it doesn't expect to receive. So it will make address zip an alien attribute. And then we have something like a location, which although is defined in a schema, is not present in the values, right? Let's just quickly parse this. Schema dot pass data, right? Expected MFO, received undefined, path gender, message required, invalid type, Boolean. We are having error of 3 properties, right? The first one that's missing is the gender. Gender isn't available here, so we'll go ahead and first add the gender value. The second property that's missing is the location property. Location was a required property, but we didn't provide it. So we'll just add a location to an empty string. And the very final one it expected was a Boolean value. Invalid type, Boolean, received undefined. And this is happening for TNC, because though TNC was an optional property, we marked all as required. So now we'll have to provide TNC also. So let's do this. Let's make TNC as truthy. Now everything is working. We have a name value, we have an age, mobile, created, gender, and TNC location. Now, if we look at the schema, we have several properties that are expected, like name, age, mobile, created, gender, TNC, and location. If you see the data, we have name, age, mobile, address, zip, is admin, created, updated, data, location, and TNC. And the value that you see here are name, age, mobile, created, gender, TNC, location. We have several properties missing from here. Is admin, address zip is not here, and we don't have. We have created, available. We don't have updated it because this wasn't there in the schema. Created is there, gender is there, mobile is there, location is there, and TNC is there, right? So what happened? So when parse gets invoked, it basically cleans up any attribute or properties that are not supposed to be there as per the schema. Our schema didn't declare address zip or isadmin or updated it as a known property to the shape that we created for it, right? And thus it cleaned it up. So we passed the user schema, and we're able to receive the value where we have all of the known properties like name, age, mobile, created, gender, location, and TSC. Now, what are the properties that we didn't receive in the value? Those properties are address is admin, updated it, right? So whenever we pass the schema result, it removes any properties that's unknown to it, right? And anything that's not defined in the schema is effectively a property that's unknown to it, right? We can easily know about this, like, which properties did got, clear while the parsing was happening by just doing this to the schema. We can mark this as a strict. We can mark this as strict, and it will be able to error out and say that address zip is admin and updated it are unrecognized keys in the object, and thus we get a kind of knowledge that there are keys getting passed that are not required, but such sort of keys are silently ignored. What's necessary is that we do have all the values that we require from an operation perspective. Now, what if we do need these values to be available in the final response, right? Address zip is admin or updated it are currently getting filtered out. Now, there is a way to let Azure, forward the properties that are unknown to it. We can just change the required. Now, there is a way to let Azure know that, few additional properties can come on the top. It doesn't matter, right? So what we can do is, instead of doing a strict, we will do pass-through. And Azure will be able to send every property, that's forwarded to it through the data entry mechanisms, right? Now we have all of those additional auxiliary and non-necessary properties also. So this mechanism can be used in several purposes. Say that, you are interested in kind of just understanding the additional keys that get passed, although there are not many practical scenarios where you need this. But just in case, if you need it, you can have this, functionality at your disposal. The base behavior is to just kind of leave things required, and if needed, kind of put this strict, sort of just to have a kind of analytic knowledge of what additional get passed in a request data or in a payload, right? Even without it, the default behavior that your ships with is kind of cleaning up any additional properties, and thus eventually what you get is what you expected. So whenever you work with JavaScript, the two most common data structures you play with are objects and arrays. Thus far we have worked with an object. Let's just see how we can work with arrays. So we have a user schema already available to us. What if we want to maintain a user list? So we can create something like user schema set array, and then we'll put user schema over here, which means that take up this schema and store it as an array of this schema under users schema. Let's just quickly inspect the type users to set info type of users schema, and it's an array. It's an array, right? As soon as you start using an array, you get few convenience method on top of it. Like you can say that something like min 1, right? Let's just quickly parse and see how this works. Console log users schema parse an empty array. 2 is small, it requires a minimum of 1. What if you remove it? It just works, right? There's no any such mandatory requirements. We can also mark this non-empty, which means again that it must have at least one item. Similarly, if you want to restrict it around the length, you can have something like min 2, right? Which means at least 2 items. This could be resolved by repeating the data that we maintain for users, right? It's working all fine for us now. And the zip parser is happy now and it's able to kind of return us the values. Similarly, we can do something like max 3, so that if the data is more than required, then it throws an error for us, right? So all the flexibility you have come to notice and realize with all the other primitives, similar functionalities and features with respect to array is also available to you to put constants around the type of the, or the structure that you would like to receive, or the count of the values or the objects you would like to receive under an array. So with this, kind of a thought through system, you get a way to declare the schema, you get a way to tell about the different constants each of the properties could hold in a schema, and then you later get ways to flexibly work with those objects. Plus on top of it, you get all of that desired TypeScript benefit of being able to magically inferring the type. So this makes Joi a real powerhouse of a data validation utility, where it's not just serving one feature, which is about the data validation of the data that you receive either through user input or through different APIs you call, but you're also able to kind of avoid the repetition that could be presented to you when you're working with TypeScript. The same data source, the same structure that you use to kind of validate the data is the structure that you use to also derive the types. And this power combo lets you eventually just be more productive with the work you are doing. I hope this video helped you in understanding how Joi solved this problem just too magically for you, and why it might be the best thing to add in your TypeScript, JavaScript, modern development workflow. See you in the next video. Bye-bye.